manufacturer and you're looking at different materials that you can use, I think Chromatic's a great opportunity to bring something in that's durable, it's elastomeric, it really takes your non-functional parts or prototype parts and turns them into durable parts that are lasting and usable. Historically, 3D printing has really been looked at as a mechanism to very efficiently create prototype designs and to be able to really for a designer to figure out what the part looks like. The reasons 3D printing has been limited in the sense that those prototypes are not durable enough to be utilized in the actual manufacturing assembly or the end-use product that you're trying to make. Really what chromatic materials changes is that whole thought process. It allows you to not only make a prototype but make a durable prototype that can be used in the end-use application. It can be tested in the application that you're making, and it can be used directly to manufacture the parts that are going to go into long-term service. Today, polyurethane products are used in a complete gamut of products, from carpet underlay to seating to bedding to coatings for products, subsea architecture coatings. So it really runs an entire range of applications. The chemistry is incredibly versatile, where it can be tailored to meet the unique needs of the end-use application. So it's a great opportunity for 3D printing to be able to customize and take advantage of the technology that's available to us in polyurethane chemistry.